Good morning, good afternoon to everyone, wherever you may be. I'm Andy Burnett. I am one of the organisers for this overall road mapping event, and I have a couple of colleagues with me. Stavros, I suppose actually just pointing from my end doesn't really help, and to my left, my colleague Tim Morley, and hopefully we'll be meeting many of you when we come to the face-to-face workshop on this. Now, in the intro, for the technical overview, Mike did mention that we're recording everything, but just in case anyone joined just after he'd said that, for full disclosure, all we're doing is we're recording these sessions and we'll put them up. There's a YouTube channel, and so everything that we say in the chat window or that anyone talks about, participants and presenters, will be available on the internet. Now, this is the first of a series of webinars which are designed to build up our collective understanding on the topics, which will then apply in the road mapping workshop. And our hope is that workshop will involve people participating both physically and virtually. So I think it's important to recognize that this is an ongoing process, but these first webinars are very important parts of the input for that. So we have assembled a panel to give us provocative thoughts. We have the opportunity to do Q&A during this webinar, and there is, if you are not aware of it already, there is a website, astrobiologyfuture.org. We encourage everyone to register there. We will be holding discussions on that following each of the webinars, and we'll then be taking the input from that, and that forms part of the input for the road mapping workshop. Now, I see I've got Sean in the group here. I don't have Michael. Sean, at this point, let me just ask, is there anything that you want to add? And I'm hoping that you have the ability to talk, because I see you're in the participants list. So if I have just silence as a... Oh, hang on.
Hello?
Excuse my ignorance. Hey, Sean. Is there anything that you want to add by way of intro for the participants on this?
I think I would just echo thanks to everyone that's going to participate, because we really value this activity and think it's important to get as much community involvement as possible in setting a future course for the field and for all of these different focus areas within it.
Brilliant. All right, thanks very much. Let me start then by just asking the panelists to introduce themselves briefly, and I'll start on my left. Victoria.
Hi, so I'm Victoria Meadows. I'm the Principal Investigator for the NASA Astrobiology Institute's Virtual Planetary Laboratory. I'm also the Director for the Astrobiology Graduate Program here at the University of Washington, and I was trained as a planetary astronomer, and I'm very interested in questions of extrasolar planet habitability.
Cool. Tori?
Hi, I'm Tori Hoehler. I'm here at NASA Ames. I am a chemist by background and then have training in oceanography. I work now mostly in microbial ecosystems, but always with an eye toward better understanding what habitability is and how organisms map to environmental conditions.
Excellent. Chris?
I'm Chris House. I'm a professor of geosciences at Penn State. I'm also the director for the Penn State Astrobiology Research Center. My background is degrees is in biochemistry and in geology, and my interest microbial life in unusual places, its metabolism, and the signatures that it leaves.
Brilliant, thank you. And Kelsi.
Hi. I'm at Washington University in St. Louis, and I just completed my PhD studying the icy moons of Jupiter and Saturn. And I'm going to be starting a postdoc looking at Earth's moons, so a little bit closer to home. And what I do is currently do is consider geology and geophysics, but my background is in astronomy.
Excellent. Okay, thank you very much. Now, Mike, at this point, I'm just going to ask, we had a slide pack which I wanted to see if I could... It's amazing, isn't it? Power of the mind.
And
to change slides, just use the arrow icons at the bottom of that share pod.
Gotcha. Thank you.
And just to remind folks, we do have a few open mics. If you can press *6, that will mute your microphone, and then we won't hear as much of the background static noise some of you might be hearing now. Thanks.
Fantastic. Thank you. Okay. When I first saw this slide, which was put together by a colleague, I have to admit, every time when I see the telescopes, it just distracts me from whatever it says next to it. So just focusing on the words for a moment. Done opens welcoming. The agenda for today is fairly straightforward, as I've already outlined. So what I wanted to do, I'm going to skip over this slide. I wanted to move to what we've actually asked the panelists to talk about. And the format we'd like to use is really just to invite whoever wants to go first on this. Michael, hello. To kick us off with our first question with regards to astrobiology for the non-scientists. So we're not looking for rather stilted responses from everyone. We want to get the thoughts, whoever wants to go first. How do you go about tackling this? And my colleague Stavros is going to monitor our chat window as well, and so every so often we might poke people with another question. Who'd like to tackle this to start with?
All right, I guess I'll jump in. Starting with the first one, how would I describe astrobiology for solar system exploration to a non-scientist? I guess I would say that there are both theoretical and practical, concrete aspects to what we do in astrobiology. And when it comes time to actually go looking, when it comes time to mount a search, you have to settle on some concrete specifics that you use to parameterize whatever tools you're observing with, or decide where to observe to begin with. And there's a certain amount that can be done here at home by examining ecosystems that we have right here, understanding life in its more general aspects. That can take you some distance along the way to deciding what those concrete specifics should be. And so, in my mind at least, this particular part of the discussion relates to how do you study and understand systems here on Earth in order to better make that search concrete.
Other thoughts?
I can say something. Oh.
Go on, Kelsi.
Okay. Yeah, so I also kind of thought we might have similar answers to this question, but I guess I just wanted to emphasize that, at least for me, the interdisciplinary nature, how we can't answer these questions about life without having all of these different fields come together. And so, besides just being a big umbrella term for all this research that can relate to life in the universe, which is a very big topic, I like the fact that it's really like we have to come together to be able to do this. We couldn't do it in our individual fields.
Chris?
Yeah, I mean, I agree with both Tori and Kelsi. I want to just, I guess, add that this is one of the central questions in astrobiology, is to ultimately take the knowledge and go out and search. And so we need both time-tested approaches and some out-of-the-box approaches. In order to get time-tested approaches, you have to use those approaches here on Earth and in different environments, past and present. And to get out-of-the-box sort of approaches, you also need to spend some effort and some time in looking at ecosystems and environments, and unusual environments as well as mundane environments. Thanks.
Victoria, do you want to add anything on that?
Yeah. So I agree. I mean, one of the major components of this theme is sort of taking what we can learn from Earth life and environments to try and understand potentially habitable environments, that might exist on solar system planets and satellites and extrasolar planets. But also, I believe part of this theme is also looking at biosignatures, and part of that is looking at sort of the effect that life has on its environment on this planet here, where we have, the only example of a known inhabited planet at the moment, and determining how those effects might be different for different environments, sort of for more non-Earth-like or non-Earth type environments. So, for example, I sort of think of, based on what I can learn about Earth biosignatures, what might I be looking for on extrasolar planets that have, say, a different composition or a different parent star, that sort of thing.
For the non-scientists, what is it that's fundamentally different about astrobiology from biology? Is it just the fact that it's more difficult? Is it hardcore biology?
I would. Sure. You want to go, Victoria? Go ahead.
Yeah, sure. I was just going to say astrobiology may not be biology at all. I mean, astrobiology is kind of a blanket term for a very interdisciplinary study. And at its core, of course, we have this search for life in the universe, but you can still be an astrobiologist and sort of study interiors of planets or whatever, as long as you're feeding into this theme of trying to understand the distribution and type of habitable worlds that might be out there. So the difference between, I think, astrobiology and biology is, biology is a specific discipline that looks at life, whereas astrobiology brings together many disciplines to answer the question of where life is in the universe and where we might find it and what it might be like.
Okay, thank you.
Yeah, I would add something to that for me goes to each of the next two questions, and that is, I think that biology has followed a path that is appropriately very specific. I mean, the revolution that's happening in biology over the last decade or so is enabled by tools that are incredibly specific to our kind of life and our kind of biochemistry. And I think one of the real critical needs in astrobiology for defining what are appropriate biosignatures, for understanding what habitability really means, is that we need to take a more general perspective and understand life in its fundamental aspects. And in some way, in some forms, that runs a little bit different to the way that biology is unfolding. I mean, a lot of the tools that we use are similar, but I think the perspective that we have to take on the life itself is different rather than an incredibly specific perspective. I think we need to be generalists. And so in some ways, the biology part in astrobiology is as much chemistry as it is biology. And for me, that becomes important in considering these next two questions as well.
Mm-hmm. Chris, earlier on I saw you flick yourself off mute. Was there something you wanted to add on there?
Well, I was just, I think Victoria had said basically what I was going to say is that one of the critical differences between astrobiology and biology, it's certainly not just hardcore biology, it is fundamentally different fields, and Victoria covered that. And I also agree with Tori that it's very much chemistry and geochemistry and geology, because we're talking about potentially looking for the chemistry of life, byproducts of life in the atmosphere, preserved metabolisms and fossil metabolisms, all kinds of things that are not necessarily what biologists do when they're very specific looking at life on Earth.
Okay. Michael, can you hear us, and do you have a mic?
Yeah, I do.
Okay. We can. So for our participants, because Michael joined just at the start of this, actually, would you like to introduce yourself?
I'm Michael New. I'm the astrobiology discipline scientist at NASA headquarters, which means I help run the astrobiology program. Part of that running the astrobiology program means putting this kind of thing together and trying to develop a broadly inclusive astrobiology roadmap.
And you were responsible, along with your colleagues, for starting to pull together some of these questions. Is there anything that you want to add in terms of describing what you do to the non-scientists? Because I imagine you must have to do this on a fairly regular basis.
Well, the usual description I give is we're looking for evidence of life in this solar system or other solar systems. And the only example of life we have is Earth. And so we try to use what we know about the origin, the evolution, the distribution of life on Earth, and the future of life on Earth, to try to extrapolate to other bodies, other places in the solar system, other places in the universe. And so that's basically my 3-second elevator speech for what it is I do.
Cool, thank you. All right, Stavros, I've been just looking out of the corner of my eye. Is there anything we want to pick up from the chat at the moment, because I see Marika.
Quite a few people were expressing their answer to the question, which I think is great, and there's a nice little back channel chat going on. We'll have about 20 minutes of comments and Q&A at the end, but please continue the back channel chatting. It's very engaging.
Having conversations in the modern...
Oh,
sorry,
I
go
was
on,
just
Kelsey.
going to say, I have a quick question for Michael New. And I don't know, obviously other people can also have answers to this question, but coming from the planetary science side, I'm actually not super familiar with what the ultimate purposes of the astrobiology roadmap are, what this document will be used for, and how it's different from decadal surveys in other fields.
Okay, so astrobiology doesn't have a decadal survey. We're a sub-part of the planetary science division. So if you go to look at the planetary science decadal survey that came out about a year ago, there is no section called astrobiology, but if you read it, ideas from astrobiology completely permeate that document. Because we never had a decadal survey per se, and because we've always wanted astrobiology to have some kind of grounding in what the community thinks is important, we've been developing these roadmaps. We did the first one in, I think, 2003. It was a revision, big major revision, and then 2008 was a minor tweak. And now it's time to really reset it and ask, what have we done, what have we accomplished, and what are our goals for the next 10 years? So in a sense, it is it's more like a science strategy than it is a decadal survey, in that it doesn't say you shall do this mission or you must do these measurements, but it lays out the science goals, objectives, and experiments that you kind of want to do. So does that help at all?
Great. All right. So we've sort of outlined our understanding of how we explain it and why it's so challenging in some ways. Let's move on to the second point about the most important research for identifying extraterrestrial life. And I have to admit, even saying extraterrestrial life, I find quite exciting. So what do we have to do? What's the critical research we've got to do? I'm very patient. Right. Go on.
I mean, I suppose this is one where we're all going to be a little bit more biased, but in my own opinion, I would say that we need to be focusing on chemistry and geochemistry that is a product of life and can indirectly tell us whether life was present, past, or active life. And the reason for that is that ultimately, when you do solar systems exploration, we're going to be talking about environments where an active biosphere could be very, very deep in a subsurface or subsurface planet or subsurface ice, or on an exoplanet. And in all these cases, potentially far removed from the observation. Or the life could be fossil life, where now the chances of finding the chemistry that organism left billions of years ago is potentially more likely than finding the actual fossil itself.
So we have a vote for geochemistry. Where else? What else should we be focusing on? Victoria.
Yes. So I want to say, I'm in a very different field to Chris. My priorities will be different. So I want to say, from my point of view, for extrasolar planets, I think we really need to focus on defining new biosignatures that aren't the standard ones associated with oxygenic photosynthesis. For Earth-like planets orbiting sun-like stars, that's sort of that's a core, and maybe we can make very good arguments for why an ecosystem will eventually evolve to support photosynthesis. But I think we need to look at these other potential atmospheric biosignatures as well, or surface biosignatures, because if we don't do this, then we lower our chances of succeeding in the search for life elsewhere, and we also lose sort of an understanding of the potential diversity of life and planetary systems out there. But to do this, what goes with this is an improved understanding of how biosignatures interact with the environment and can be discriminated in the context of the environment. And So I think that study as well will probably inform all this other biosignature research as well, which looks at, again, life leaving its imprint on a planetary environment, whether it be on Mars or Europa or wherever.
Out of curiosity, have we found anything that would indicate alternative, and I know I'm being slightly self-indulgent here, but have we found any alternative signatures?
What I'm talking about here is looking at, you might not think of it so much an alternative signature, but an alternative dominance. So, for example, you could have a biosphere that's dominated by sulfur metabolizing bacteria, for example, and that will produce a very different signature in the atmosphere than say, oxygenic photosynthesis from plants. So I think we can certainly look at different metabolic pathways, different metabolic byproducts, and how those interact with the planet's environment, and also the light that's coming in from its parent star. Because if the light from the parent star changes, that changes the photochemistry in the atmosphere, and it changes what kind of signature you get. So these alternative biosignatures are kind of a function of three different steps, alternative metabolism, dominant metabolism, making them, their journey within their own atmosphere, and how they're affected by the light from their different parent star in a different atmosphere, for example, and then ultimately what we might see in the spectrum for these things.
Thanks. Okay. Tori.
I'll add a bit to what Chris and Vicki both have said, because I think they're talking about different sides of the same coin. They're in each case talking about features that are products of life processes, but not the life itself. And in both cases, I think the real concern is understanding, because these are features that might well arise from non-living processes as well, and features that inherently don't contain a huge amount of specific information. There's a danger in mistaking them for in getting false positives, I think, from abiotic processes. And so I think for features that are meant to serve as evidence of life processes but not life itself, I think there's an important standard that sort of has to be met. When does that feature rise to the level of saying, okay, this is different enough that although it's not life itself, we can't envision it having come from anything other than life processes. So I think it's a question of degree when we talk about these features. And then on the other hand, when you do go looking for the life itself, for molecules or features that may be a product of life, I think there's a different concern, and that is, we understand how to recognize something as specific as the molecules of our own biochemistry, but there's a danger then in going looking for those specific molecules or features something like them. So how do you understand how to look for a very specific thing, something that does carry so much information that it's a clear representative of life, but is not in the specific line that our biochemistry has chosen? And I think all of those are challenges we face.
Okay. Kelsi? Ooh, looks like her video may have frozen.
Right.
Kelsi, are you still with us on audio?
Yeah. Can you hear me now? Okay.
Yes.
So I, from my bias working in the outer solar system, it's kind of similar to other people. I'm basically interested in learning more about what we could actually potentially check for when we send spacecraft, and really we're still at the point of we need to gather a lot of other basic data, but it's still good to look forward and think about what would actually be able to be detected in these kind of environments. So for us, it's icy moons. So it's very similar to what other people have said.
So just coming back to slightly more detailed questions, we're thinking about the most important research to conduct. If you were given reasonably large amounts of money, you had to spend it on something to move the field forward, but you could only do one thing, what would you spend the money on? Kelsi, start with you.
Sure. I guess it's kind of similar to my last answer. But for us in the outer solar system, we have some really fascinating moons that could definitely, potentially be places life could exist. And, of course, there's been lots of speculation about that, just because there is liquid water in a lot of cases, and other things that are considered necessary for life. So for us, we would love to, spend lots of money sending spacecraft out there, and basically even getting information about these surfaces. We use the surface information to understand the interior and the potential environments in there. there's places in the outer solar system that haven't even been imaged. So we have a lot of work to do, and certainly just basic, imaging, spectroscopy, radar for subsurface imaging of icy worlds. That would be great for us.
So is it a case that the technology that we have is good enough, we just have to get it out there, or are there still significant barriers in terms of resolution and this sort of thing?
Well, it depends on the world. For some place like Europa, there's a lot of technology that hasn't been sent. The last mission ended in the early 2000s. So as you can imagine, there's a lot that could be sent there, especially something like an ice-penetrating radar. In other worlds, some technology development does need to be done. In some cases, even for Europa, it would be helpful to have better radiation-hard products. But in some cases, just to get the mass to the outer solar system, we need some more creative technologies, either for power systems or for somehow capturing spacecraft into orbit. So it's both.
Okay. Chris, where would you spend your embarrassingly large check?
Well, I think I've seen the chat room open up with everyone's favorite mission, and there are a lot of great missions that people have dreamt up, and I'm going to stay agnostic in that debate. Although I will second Kelsi's plea that we need to get back to the outer solar system. Now, within the outer solar system, there's at least 3 or 4 places that we need to get back to. So I'm going to stay neutral there. In terms of the astrobiology budget, which is usually not a missions budget, I think that we do need to be developing better both time-tested approaches to life detection and out-of-the-box approaches. And that's not just for, rock samples. That includes Victoria's plea about atmospheric signatures. I completely agree with her that worlds that didn't generate oxygen are the most likely worlds to see. And in the next, if we talk about a decade here as our time scale, that's the right time scale for starting to get some first data on exoplanet atmospheres around red dwarfs. Around red dwarfs. So I think that's where I would put my embarrassingly large amount of money is into work on metabolisms and the potential signatures they would produce that might inform both the Mars mission, there to be a rover in 2020, as well as these initial exoplanet missions.
Excellent. Thank you. Always good to know we won't have difficulty spending the money. Tori, what do you want to add to it?
So I would pick up a theme that Vicki raised earlier, and I also thought it was kind of interesting that I don't think you'd finished speaking that sentence before mission wishes started to pop up in the chat. But I mean, suppose that thing could launch tomorrow. Do we feel like we have the context from observation and theory to say exactly what instruments should go on that spacecraft, and to be sure that having spent the money, whatever we see, that we knew a clear signature that we were looking for. Do we understand enough about the context in which that signature is formed that we could do a good concrete job of saying, you spent the money and here's the answer? So I think that money to go into the sorts of things that Vicki was talking about earlier, understanding the environmental context, how is it that what you're looking for interacts with its host environment in ways that may give you false positive or erase a positive signature, are critical, and that is within the scope of astrobiology.
And is that something we can quite happily do on Earth? Can we simulate it, throw large enough computers at it? Is it that kind of problem, or have we got to go to ground truth out there?
I think it's a mixture of things. I think it's an iteration between theory and modeling, between observations that can be done in environments here that may not be perfect examples of what we're looking at elsewhere, but in which we can identify some features that make them similar, and then whatever we're able to do with observations that may not be specifically targeted at the life question, but nonetheless give us enough contextual information about the potential target that we understand better how it is that our ultimate signature of life is going to interact with that environment.
Great. Well, Vicki, seeing as everyone is name-checking you, let me come back to you. Where are you going to spend the money?
Well, where am I going to spend it? I mean, truly embarrassingly large amounts of money would go on TPF, but we don't have that kind of money. So again, from the astrobiology perspective, I absolutely agree. I put forward this sort of meme that we need these novel biosignatures. I agree with Tori. We need to know about false positives, but it's not just so that we can interpret the data when it comes back, to lay that solid scientific foundation for the interpretation of our search for life elsewhere, which I think, of course, is fundamental to astrobiology, but it's also to drive the design of those missions as well, and I think that must not be forgotten, that sort of the more we know about the different types of things we'll be looking for, the better case we'll have for driving sort of the requirements, whether it be large spectral wavelengths or high spectral resolution or whatever, that we will require to measure these things. So I think that's also crucial, is to know as much as possible beforehand so we can build the best possible instrument to do the measurements.
So in that case, in my mind, given very limited understanding, this sort of segues on perhaps to our last question then about defining a habitable environment. So let me ask you to unmute yourself again, Vicky, for a moment, and just think about what is it we need to do? Is it a natural segue from what you said in order to be able to define research and define the habitable environments?
Yeah, that's certainly part of it. It falls into this idea of being able to look at something. In my case, again, I'll speak for extrasolar planets, but this is true of remote sensing of any body in the solar system, including icy moons or Mars. But being able to get information from an environment and determine whether or not it is habitable. And I think, first off, back to the biology, we need to understand life's limitations. And we need to understand not only life's limitations, but in the case of exoplanets or different environments, how those limitations might be affected by that environment. So a specific example, for example, is, how far can we go with oxygenic photosynthesis as far as the wavelength of light that's required, and how would that light environment change on a planet around another star? But this question sort of feeds into the main issue, which is an improved understanding of the interaction between planetary characteristics, what the planet's like, stellar characteristics, what the star's like and how that interacts with the planet, and then the interaction of other objects in the planetary system. So for us, habitability is really a huge field where we're trying to sort of get beyond the classical habitable zone and understand, which is a great formalism to start with, but to understand all the different factors that now affect that. And so in that sense, if we know where the habitable zone is or can constrain it for the highest probability, then that allows us to target the sort of planets that we want to search for and the sort of planets that we want to follow up with instrumentation, because those observations are going to be extremely expensive. So in summary, I need to understand life's limitations. I need to understand the interplay of all the components that go towards habitability. I need to get that habitable zone defined so that I know where to look and I know how to prioritize my targets to look more at.
Thank you. And I'm just going to ask you to define one term because I noticed it popped up in the chat window. TPF.
Oh, yes, sorry. So that's Terrestrial Planet Finder. It's a sort of flagship mission class, probably even larger, if there is such a thing, mission that will be a very, very large telescope that will allow us to get spectra of extrasolar planets orbiting around other stars and therefore allow us to directly sample and study their environments remotely.
Brilliant. Thank you. Sounds like the sort of thing one might spend money on, large amounts. Tori, back to this question about the research that needs to be done to define inhabitable environments.
Yeah, I guess I would toss out two things in regard to this question. And the first is, I think that we can and should do more in order to understand when we look at life on Earth and take it as an example or a basis for defining habitability. I think we should do a better job of understanding which of the features, the limitations, the capabilities we're seeing relate to core properties of life and which are specific choices of our kind of life and our kind of biochemistry. So in other words, I think we should make the best use of the example we have by saying, characteristics A, B, and C, we can expect to be fairly universal for whatever reason. But these other features of life are such specific choices that we really shouldn't feel too tied to them as we try to understand habitability elsewhere. So I think defining better what is a core set of features for life in order to understand and define what is core habitability is important. The other thing that I would point to is I think that habitability at least as it's been defined on paper, has been largely a sort of binary concept. Either an environment is habitable or it's not. In the happy event that we're presented with a number of targets for observation, any of which might conceivably be called habitable in a binary sense, life could conceivably exist there. How do you prioritize among them? How do you say that one environment is more habitable than another, represents a better choice for observation, may have a better signal to noise when you ultimately go looking? And that's something that I think maybe we all have notions about, but that we haven't really tackled in a very concrete way yet. So those would be the two things that I think represent areas for progress, at least, when we talk about habitability.
Excellent. Thank you. Chris?
Yep.
Thoughts on defining the research that we need to define habitable environments?
Yeah, let me think. I think we need to be careful here. You know, in the past we've been rather comfortable to stay within our comfort zone defined by life on Earth, and we push that boundary to extreme environments, and we should continue to do that. Deep subsurface and high temperature and cold temperature, and alkaline and acidic, and all the various ways to approach that problem. But you know, since this particular week is devoted to solar systems exploration, I think that we need to also recognize that we need to push that comfort zone beyond what ever occurred on Earth to what didn't occur on Earth but could have occurred elsewhere. And so that's going to mean that we need to spend a little more time on what sometimes is called as weird life, different solvents and different ways that life might have formed when you start to talk about planets and moons that are very different than Earth.
Okay, thank you. Kelsi, anything you want to add on this?
Yeah, it's kind of similar to my answer to what was the last question. But yeah, I was thinking very similar to sort of what other people have said. There's the two aspects being like what, besides life as we know it, what are the extremes? And that's really helpful for other places in the solar system, but also understanding the other places. So it just, to me, it's the same as everyone has said. There's kind of those two coming at it from both directions, the environments elsewhere and also what is possible on Earth.
Sorry. Oh, there was a slight video lag there. Let me, in that case, just direct your attention. I'm hoping all of our panelists can see the little panel called Live Notes 2, because while we've been talking, Stavros has been culling from the chat room. And it seems as though there are several people who are interested in places other than icy moons. And I was curious, are extreme environments on Earth or Mars, are they equally useful for us, or in order to understand habitability and the identifying extraterrestrial life? Sorry, Chris. Go on.
Yeah, I think I noticed that comment, and if you look at the research that the people on the panel do, I think that really it's actually balanced. Tori and I work on microbial life and extreme environments and weird metabolisms and weird places on Earth that is really very focused on planets, where Kelsi and Victoria are more on icy moons and exoplanets, respectively. So I'm sorry that it came across that way, but certainly that was the flow of the discussion, not necessarily the bias of the panel. And hopefully, as we open this up for the next 30 minutes, we can have a lot of discussion about solar system targets other than icy moons and exoplanets. Certainly the Mars program it should be discussed as well as other potential targets.
So that seems like a good segue to open it up. Now, Mike, we might need your help here. I know people can raise their hands. Do you then turn on their mics? What seems to work best as our approach here?
So all the mics are open, but if you want to do the raise hand as a form of protocol, just so people don't talk over each other, that could be helpful. So if people want to do that, there's an icon at the top of your screen with the person who looks like they're raising their hand. If you click that and say raise hand, we'll know that you want to speak up and we'll call on you.
So, mics are now open. Wayne, first in there, like a shot. Go right ahead.
All right, can you hear me?
Yes, we can.
Okay, very good. I was kind of the one that threw in the comment about possible skewing of the panel, and I didn't mean to offend anybody. I just wanted to bring the discussion a little back towards something that we have quite a bit more ground truth for. Exoplanets, it's a lot of observation from a distance. Icy moons, we have some physical and chemical data, but obviously landing and sampling would give us a lot more data than we have. But at the moment, we have quite a bit of ground data from Mars, from sampling of the environment, not only the atmospheric environment and the physical temperature, radiation environment, but also quite a bit of data about the soil and the regolith itself. And this is something that we can take right into the laboratory and look for Earth microbes which can grow and survive under those conditions. And we can actually physically test the attributes of microbial life that allows them to grow in a very close simulation of the Martian environment. And, when you compare that with the wealth of data we have about what's underneath the surface of an icy moon or what's circling a star several light years away, there's no comparison. And we're really making some really interesting strides in defining what it is about a microbial cell that allows it to grow at low pressure or extreme low temperature or in the presence of radiation or strong oxidants. And so I wouldn't rule out Mars as somewhere where we've just been there and done that and move on. I guess that's my point.
Anyone want to comment on that? No?
Well, I completely agree. I completely agree, and we're at Mars. We're at Mars with 2 rovers, and we're going to be going to Mars with another rover. And so there's no question that in the short term and the medium term, a lot of effort in astrobiology needs to be geared toward that particular planetary setting, and that should be both for present life on Mars near the surface and more deeply buried life, and also past life.
I'm conscious of time, so at this point I'd like to ask Kenda Lynch. Your mic should
Yes, I'm here. Can everybody hear me?
Yes, we can.
Great. So I just wanted to address a statement that Tori in Tori's comments about habitability and, it being binary or not, and how do we start to prioritize? Because clearly we have a lot of habitable environments, but given our known budget constraints that we have and will continue to have in the foreseeable future, we do need to prioritize. And one of the things that I see that we need to do more is not necessarily a specific aspect of a new direction of research, but I think it's in considering the connectivity of the work that we have done and the context of the environments that we've studied here on Earth and how they're applied to these other planetary environments. So we need to understand not only, is an environment habitable, can it produce biosignatures, but what is the connectivity between it being habitable both in the past and in the present? What is that connectivity to the possibility of life originating in that potential habitable environment? What is the connectivity to that environment being accessible with our mission goals? We need to create this connectivity between these different aspects at each habitable environment. And in that way, we should be able to develop a way to prioritize which environments do we want to target for study with our limited mission resources. So that's something that I think astrobiologists can participate more in on the mission front because, for example, I was just at an early Mars meeting, and all of the mission people who are almost all pure geologists or planetary scientists, there was a group of astrobiologists there, and when they said, hey, astrobiologists, where should we look? The answer was all over the place. There was no coordinated, focused, considered metric of how to answer that question, and I think that's something that we as the astrobiology community need to focus on in this next roadmap to make sure that we can get our voices heard for missions. I'm done.
Tori, thank you. Tori, do you want to add anything to that?
Not so much add to what Ken just said. It just sparked another thought for me, which is, this question of time in habitability is something I don't think is addressed all that much. And in particular, for me, it raises an issue that I usually think of it in reference to extant life. How would extant life fare if dropped into this environment? Would it proliferate? Would it barely limp along? But there's a second question that isn't addressed quite so often, and that is how conducive is an environment to having life originate in the first place? That's a very difficult question to answer because I don't think we understand how that process happens at all. But it's a much more restrictive set of conditions, certainly, and so trying to bring some notion of time and origins into the question of habitability is a key thing, I think.
Just probably one other question. Murthy, and I see you've got your hand up.
Yeah, this is Murthy Guripati, JPL. I think one of the key differences between astrobiology and biology is, as I said in my chart, to see how far life could have evolved. That means the prebiotic evolution as well on other solar system objects, rather than just go and look for whether it is habitable or whether it has life or not, like binary, as Tori was telling. And for that reason, I think we need to really focus on science much more than missions. But don't mistake me, because I do support strongly that we should also get involved in mission-supported research. But as I also mentioned in my chart, we should not be a subordinate of a mission, because then the independence of the astrobiology research will be gone. So though we, as Kendra said just now, that the Mars community needs to know what astrobiology is offering them, we should not become a subset of Mars biological potential and things like that. So we should keep our independence and connect with the missions, but our goal should be actually finding the mission of NAI as well as NASA, that is, how far life has come elsewhere and how can we detect it. Thank you.
Thank you. Okay, it doesn't look as though anyone else has their hand up at the moment. I'm just scrolling through my list here. Let me just ask the participants on the call out there, does anyone want to advocate for a particular area of research? I'm thinking particularly about the second question about determine the set of criteria for identifying extraterrestrial life. And, of course, the third question as well. There's sort of a lot of chat I've seen in the chat room. Does anyone want to expand upon what they've said for the record?
Yeah, let me say something. It's Ron Breslow. Am I in there, or do I have to press some button in order to be heard?
You are in. You are live and direct. Go right
Okay, yeah. There's another part of this which is in fact supported by the astrobiology system, and which I think is quite important. And it's an earlier question than anybody has ever asked. That is, how did life start here? And the question really comes down to things like, where did you get the appropriate chemical environment such that the chemicals were there? After all, they can't be produced by life. It comes later, right? So where did we get all the chemicals? And the most curious one about our chemicals is that we have selective chirality in all these chemicals. The amino acids are what are called L-amino acids, like your left hand, and the sugars are D sugars, like your right hand. And yet spontaneous chemistry, without life around to direct it, doesn't lead to that kind of thing. So where did it come from? And that's where a very exciting new thing which has happened has really opened up this field. That is, meteorites landing here have arrived with some excess chirality, and people spend their time trying to figure out where it came from, but what we spend our time with is saying, how does that then steer all the chirality on Earth so that you get the L-amino acids you need and the D sugars that you need in a sensible, non-vital way, not having nothing to do with life, but having to do with prebiotic life, getting it ready. Now, that means, of course, that it's a good chance that one has to have something like that going wherever life is going to be. It's not going to suddenly appear without the chemicals that comprise it. And, of course, they could be different chemicals from ours, but still, they're very unlikely to be flat chemicals which have no sense of left or right. It's just any sensible, reasonable large molecule has that thing. And so then the question is, one of the things that's quite interesting, why did we end up with left rather than right amino acids? Why did we end up with right rather than left sugars? How did that all come about? And is it possible that in other environments it would be reversed? So people are quite interested in the possibility that life somewhere else might be the mirror image of what's going on here. And that, even finding that chirality somewhere, would be really exciting because, as I say, it's not what you get spontaneously except for this special situation in meteorites landing here, which are bringing in something that was developed outside of our atmosphere by probably right circularly polarized light, but even that hasn't been detected and identified yet. So there's a lot of that has to be worked on. But what we're doing right now is just trying to figure out what spontaneous chemistry can make the things that are needed for DNA and for proteins, for all the things that, at least in our version of life, are critical.
So, Ron, let me ask you in that case that I shouldn't limit the spending the very large amounts of money just to the panelists. Where would you write the check if you wanted to advance that?
Well, yes, I have an idea.
Well, I can probably think of where you would do it. The minimum thing I would like to do, I have a colleague actually who has support from NASA named Amber Miller. She looks at the light outside our atmosphere that is a residuum of the light that was originally emitted during the Big Bang. So it's obviously quite far back from when life got around. But she and I would like to send up an observer to get outside our atmosphere and see whether we have, in fact, an excess of right circularly polarized light, which is the one that really makes the most sense for why it is we have the chirality we have. But it's one thing to say that it must be there, and another thing, as you know, as a scientist, to see, and sure enough, there it is. So I would like to put, it's not a huge amount of money, but it's some amount of money to let us send up. What Amber does, she sends up a balloon to the edge of the atmosphere, and then she can pick up the extra atmospheric light, and that's what we really would like to do. It's modest, but not negligible.
Excellent, thank you. Michael, is there anything that you want to add to the discussion so far?
No, I think there's been some good conversation, especially in the chat window. I'm a little bit surprised that nobody's jumped forward with their favorite set of criteria or the discussion of what makes an environment habitable, since these are pretty topics usually at conferences. So I would like to know what people think about, what do we need to do to define an environment as habitable? We have this basic triad we talk about of water, nutrients, and free energy differences. But beyond that, that's pretty, other than saying water, it's pretty high level, pretty abstract in a way. And so I would be curious to know what people think we need to actually go and do to find out what makes it happen.
So it's what do we have to do to define habitability?
Well, basically, it's your third question,
Yeah, okay. Oh, Mercy, you want to come back on that?
Yeah, I just wanted to, touch upon Mike's question, but before that, I want to disambiguate my earlier statement is saying that the astrobiology research should actually lead and strengthen the missions, and the missions needs should be catered partly by astrobiology research. But these two should not be, totally coupled together to lose the independence of astrobiology research. Okay, that's my statement, earlier statement. Now, coming back to Michael's, habitability environments, I think we need to also put a qualifier here saying as we think of life in the context of Earth. So that's a very important thing. Once we put that qualifier, then it boils down to, as Mike said, a few key aspects. One is the liquid water for the mobility, and then the nutrients and the energy, and the electrical, let's say, dipole forces. That means there should be a gradient. So these are the, of course, organics. Of course, organics. Without organics, as we think of life, there is no life. So all these are the 5, key aspects. And I think majority of, the potentially habitable environments in our solar system actually qualify for this. For example, the subsurface of Titan qualifies for this, and subsurface of Europa qualifies for this, and probably even Mars subsurface qualifies for this, and even probably the surface of Mars would have qualified earlier. So that's my take about the habitable environments.
Thank you. And with that, we will draw it to a close. I would just like to draw everyone's attention to the website, which Stavros has just typed up in the middle chat window. If you're not registered on astrobiologyfuture.org already, please do so. We are now going to take these questions and encourage you to add others. You'll find that there is a discussion forum. We've popped up a couple of starting categories, one around interesting ideas and the other around exciting questions. Please don't feel constrained by those. If you want to start other categories, do so. But really what we're looking to do is over the next week to capture any thoughts that you've had as you go out walking your dog, having a shower, and you think, that's what I should have asked them. Please don't lose it. Put it in the discussion forum, and that will help to drive the process for the road mapping activity. So with that, thank you very much to our panelists, and I hope to see everyone at the next event. Cheerio. Bye-bye.